Well, hello everyone. My name is Ken Osborn. I'm an Edge and IoT SE. Really excited to be here today to talk to you about what VMware is doing in the IoT space. From an agenda perspective, I'll go over some basic terminology, give you an overview on how to quickly get started with IoT yourselves, maybe in your own home lab. I'll then spin through some scenarios on using Pulse IoT Center to help manage your IoT devices. And then I'll spin through a demo to give you a visual feel on what we're doing with managing IoT devices. So just some basic terminology. I really love this IoT definition. It essentially defines IoT as combining the physical world with computer systems to distribute data over existing networks. So not overly complex, and maybe not unlike what you're already used to in the data center, but where it starts getting interesting at the edge is when we introduce edge systems. And these edge systems are comprised of gateways and connected things. And you can think of gateways as low-powered, fanless, lower-cost compute devices, like a Raspberry Pi is a perfect example, whereas the connected things are communicating with those gateways, and they're things like cameras, sensors, actuators. The other thing worth mentioning here that a lot of people in IT aren't as familiar with is OT. And OT is operational technology, and think of these folks as the resources that are wearing the hard hats in the manufacturing plants, they're pushing the medical carts in the hospitals, and they're not necessarily in tune with all the decades of experience that IT has in managing infrastructure. So we think there's a really great opportunity to combine those two worlds, take the expertise from IT to help the OT resources securely manage their IoT devices. So the fastest way that you can get started with IoT is just pick up a Raspberry Pi. You probably already have 10 of them, laying around in your house, but you may not have a SenseHat board. And if you're not familiar with a SenseHat, this was created a couple years ago, and it was termed Astro Pi and sent into space with a British astronaut named Tim Peake. And it allowed kids to do some environmental monitoring in space. So if you examine some of the temperature sensors that are on the SenseHat board, you'll see there's humidity, barometric pressure, and temperature readouts that you can get. And all you need to do is plug that SenseHat board into your Raspberry Pi. And what's great about this is the way that you'll interact with that SenseHat board is by using Python. And Python is not something to be afraid of. If you've ever done any basic coding or scripting, it's very similar. And it's very prevalent in the IoT world. So with the SenseHat board, there's a number of really great getting started tutorials online, including this one from Raspberry Pi Foundation, where they walk you through how to interact with the SenseHat board writing Python scripts. And they don't just tell you step by step what to do. If it's kind of familiar to the scratch a sniff, I don't know if you have those here, but if you use a yellow marker to reveal the answer at the end, you have that at the end of this. It'll actually show you the actual script, but it sort of guides you by the hand before that to build out the script. So really encourage you to pick up one of these. If you want to get more advanced with IoT, there's a NVIDIA Jetson Nano board, and it's using an NVIDIA GPU and a quad-core ARM processor. And with that, you can do edge analytics and artificial intelligence and image recognition, all with a very inexpensive connected camera. So just a few more examples of what we define by edge gateways and things. Here we're looking at a hardened Raspberry Pi board that you would find in an industrial setting. This is a Dell IoT gateway. In Europe, Sorba IoT gateways are quite common. And then on the connected thing front, you have a wide range of devices here. Prevalence of IoT cameras, many actuators, so converting motion into energy and energy into motion. You find these in manufacturing floors. And then there's a huge range of connected sensors. So everything from a temperature sensor to a gas leak sensor to vibration, motion detector. You have all of these in the portfolio of connected things that you can bring to bear for IoT use cases. So I do think it's important to try to define, what we mean by being at the edge. And we call it, living at the edge. And sometimes when you're defining concepts, it helps to compare and contrast to things that you're already really familiar with. And I'm guessing that many of us here are very familiar with raised floor data center environment, right? And arguably, maybe we take for granted some of the things that a raised floor data center provides, like redundant power, plenty of racks of compute and storage to architect with and consume from, many applications that are existing in the data center that are traversing that data center environment. Lots of really smart people like yourselves, especially you, Ariel, that know how to traverse the data center and all these systems and processes that you've put in place over the years to manage and monitor the data center. So one possible definition of living at the edge is to strip away everything that you're familiar with. And instead, you may find yourself with a low-powered, fanless gateway. And these gateways can reside anywhere. They could be on top of the tallest mountain on a weather mast, gathering environmental data like temperature, humidity, wind speed. They could be sitting out in remote locations like an oil refinery field or an oil rig. And perhaps there's containerized lightweight applications that are doing interesting things like communicating with an IoT camera to count the number of orange pixels in a refinery flare to determine heat intensity and adjusting that temperature accordingly. These gateways can be sitting out in remote locations or manufacturing plants. And again, lightweight applications running on them that are doing interesting things in the environment, like monitoring the environment before they allow heavy machinery to be turned on, or monitoring a production line to determine if there are quality issues before waste ensues. So one commonality in all of the use cases are the applications themselves. And this is perhaps the most visible part of IoT, kind of the sexy part of IoT. And this is where businesses are really transforming what it is they're able to deliver and optimizing their processes because they have access to connected thing data that they may not have had previously. And we refer to this as the content plane. So in other words, the content being the data that's coming off of the connected things. And this is where you'll typically find data scientists that are trying to make sense of all that ingested data and have it be applicable to their lines of business. I'll give you an example. In the United States, we have a fast food restaurant, and they have over 40 IoT devices in each restaurant. There are cameras that are sitting above the cooking pans, so they not only know whether or not something's being cooked, but how long it's been cooked for. There are cameras that are trained on the parking lot, so they understand the amount of foot traffic that's coming into the restaurant. They have IoT sensors that are in the meat lockers that are gauging the temperature of the frozen meat. And they're triangulating all of that connected thing data with the point of sale system in an IoT platform. And that platform could be Azure IoT, AWS Greengrass, it could be Google Cloud. So again, a lot of smart people at the application tier, a lot of data ingestion and analysis going on, but equally as important to the application tier are those things that are lurking below the water. That if you don't have a handle on, it doesn't matter how good your team is above the water, if the devices aren't actually online, or if they're online and they're melting down because they're overutilized, or if there's a bad actor in the environment who's uncovered a security deficiency and you don't have a one-to-many way to blast firmware updates out there, then all that hard work at the top could be for naught. And we refer to this as the control plane, and it's classic VMware. What's old is new again. All we're doing is giving our customers a layer of abstraction through software that, regardless of the underlying IoT hardware type, we enable that single control plane to onboard, monitor, manage, and secure those devices. And no different than back in the day with vSphere and vCenter, giving customers choice on the server OEM that they want to bring into their environment. So we see both of these, the content and the control plane, as a single entity, one IoT infrastructure, if you will. Pick whatever analogy you want, both sides of the same coin, wine and tapas. In the States, I say cheeseburger and fries. But we see companies that are racing ahead in the content plane because they're caught up in the sexy nature of IoT. And they want to innovate and deliver value for their companies. All of us do. And it's fun to work with IoT. To me, it feels like the early computing days, where there wasn't a manual on how to do things. Even the early virtualization days, where we had RTFM Edu, Michelle Laverick, but beyond that, there wasn't a whole lot. So companies are racing ahead in the content plane, but they reach a slow burn moment where they're like, how am I going to manage all of these devices? And maybe they have 5 or 6 different IoT devices, 5 or 6 different ways to manage them, 5 or 6 different service contracts that they have to reconcile. So what VMware is trying to do with Pulse IoT Center is enable that single control plane. So I've heard Pulse IoT Center compared to vCenter as the vCenter of IoT. It's not a perfect analogy, but it's close enough. We also have EUC capability, sort of IoT for people that carry devices. But what I'd like to focus on next is give you a taste of what we're doing specific to Pulse IoT Center. And in order to onboard and monitor these devices, we have to go through a process. We create a template in Pulse. We require an agent on that edge gateway that I talked about earlier. And then we enable customers to securely onboard those gateways, all the way from a manual process of typing things in to completely streamlined and automated for onboarding thousands of IoT gateways. So I'll give you a little demo here and an example of what that looks like. I'm just going to log into Pulse IoT Center here. And what we're looking at is Pulse IoT Center version 2.0. We came to market with this in May of this year. At VMworld US, we announced an on-premises version. This particular flavor is running in SaaS, VMware Cloud on AWS. And we just have some high-level dashboards here. A SOC or a NOC, as part of their daily run operations center, may want to manage down the number of critical alerts that are in the environment. But let's drill down on our devices here. And here what you're seeing is a list of all the gateways, edge gateways, and things that are under Pulse management. And today we classify these by those 2 different device types, a gateway or a thing. And think of a gateway as something that we can install our agent on. It's running an operating system. Whereas a connected thing, a camera, a sensor, we may not be able to install that agent on, but as long as it's communicating with the gateway, we can interact with it in meaningful ways. So what I'm going to do is pre-register a gateway here. We'll give it a name, and I'll tie it to a template, and I'll explain what templates are in a moment here. We'll go ahead and register this. And I'm going to go into the actions menu of what we just registered and create an onboard credential. So here I'll just paste in a serial number. We're using property-based. With property-based, we suggest that you use something unique about the gateway, like a MAC address or a serial number. I'll go ahead and create that and close this out. And now what we can see is that the gateway is in a registered state. It's not fully enrolled yet. So here's where I would ask you to use your power of imagination. Imagine we had a physical gateway. We hit the power button on it. It has our agent built into the image, and it's using a Linux utility called DMI decode to retrieve the serial number of the system board and pass that into Pulse in order to complete the registration cycle. So we power that on. If you blink, you'll miss it. It switches to an enrolled state. And while we wait for that gateway to send its data to Pulse, let's explore device templates. So what we're looking at here are a catalog of all the various templates that you can build depending on your use case. We've got temperature sensor array templates, IoT security cameras, Docker containers, Dell gateways, Raspberry Pis. I'm going to edit the template that we use to enroll the gateway with. You'll see that we give it a name, we select its device type. I'll click next here. Now we have customizable properties that we can retrieve off of the gateway and ingest into Pulse. Things like whether or not SSH is enabled, what operating system is it running, as well as custom properties. So any VI admin will recognize custom properties as very similar to vCenter tags. So think of this as metadata that you can do interesting things with in other areas of Pulse IoT Center. I'll click next here, and now we're looking at the default metrics that we pull off of the gateway. Utilization related, CPU, memory, disk. You can also wire in custom metrics if you have services or containers that are running on the gateway. You can wire them in as Boolean values, up or down, over a series of time. I'll click next, and here we have a list of connected things. So in this scenario, we want to connect an IoT camera. We want a camera or a Docker container to be running on the gateway that's interacting with the camera, and then a set of environmental monitoring sensors. So these are also described in templates, and we've whitelisted them here in order to allow them to communicate with that gateway and send data to Pulse. The next area here is a menu of commands that can be sent remotely from Pulse without having to actually SSH into the gateway. So think of these as anything a human can do when they're logged into the gateway. Type a command, run a bash script, instantiate Python, start Docker containers. We can do all of that remotely through a send command. And the last area is enrollment provider. I mentioned that we're using property-based. So we entered a serial number in this case, a unique identifier. You can also generate time-based tokens that expire in minutes, weeks, months. We have new capabilities that you didn't see here, like TPM. We can take advantage of a TPM chip in an Intel-based gateway to securely onboard that gateway. We have zero-touch onboarding. I call that feature the Who's My Mommy, because the gateway is sort of born into the world. It doesn't know who it is, who it should talk to. And what happens is it comes online. It has a BitLoader on the gateway installed at the factory. At boot, it phones into an intermediary server that contains the mapping information of who it should talk to, who it is. And it also streamlines that agent installation process. And then the last item that we have is a mobile app enrollment. So a technician that's deploying these gateways can scan a QR code with their mobile device to complete the enrollment process. So I'll exit out of here. We'll go back and look at our devices, and I'll set a filter on this gateway. And by now we should have started ingesting data. So I'll drill down on the gateway, and we can see the properties that operationally and at scale you may care about with regards to those under the water items. Is the gateway actually online? What operating system is it running? Is SSH enabled or not? Does it have Docker installed? If so, how many Docker containers are currently running? We also pull in those time-based series metrics here, like CPU, memory, and disk utilization. And because we're ingesting this data into Pulse, we can send meaningful alerts to people that might care about the state of the gateway. We also visually illustrate the relationship between the gateway and any connected things. And these connected things don't have to be physical devices. In this case, they can be logical devices like Docker containers. So I'll drill down on the Docker container, and you'll see a similar theme. We have basic information as well as properties about that container, what image is running, is the container actually online or not, as well as utilization metrics. In this case, I've just wired in CPU utilization and the run state of the container. Is it up or down? But you could pull in whatever metrics you wanted in addition. So we'll take a look at another connected thing to this edge gateway, a sensor array. And here we're pulling back that environmental information, like temperature, humidity, and wind speed. So in this case, if you recall the iceberg slide, I've kind of gone above the water into the application space. And you may not be looking to Pulse in order to consume that data. You may have an existing IoT platform, again, like Azure, AWS, or Google, that's performing this role for you. But if not, Pulse can certainly handle that as well. And then the last item we have here is a security camera. So examining that, we see, again, a recurring theme here, operational information that you may care about with regards to this connected thing, like firmware versioning. And I'm not going to show you here today, but I mentioned earlier, if there's a security deficiency across tens of thousands of your deployed IoT devices, Pulse can send a campaign or a package out and rev that firmware version to a new version. The last thing I'll show you with regards to the gateway is our send command functionality. So I'll select commands here, send command, and here you're seeing that list of options that I showed you earlier in the template. So these are all things that you can do remotely via Pulse without having to SSH in. You could turn SSH on or off if you want to do some triaging and troubleshooting, reboot the gateway. You could inspect logs remotely like an auth log or a boot log. And again, whatever command someone can type manually when they're logged into the gateway, we can configure here as a send command. So last thing I'll show you here is, because we have visibility to all these deployed edge gateways and devices, we can send meaningful alerts as to the condition of those devices. And we do that through our alert definitions. And so I'm just going to go into alert definitions here and select create. We'll give this a name. Let's key off a CPU utilization above 90%. We'll tie this into a template, the same template that we onboarded the gateway with. We'll select a severity. I'll give it a critical severity here. And now we have the option to set very binary alerts, offline alerts. Something's either running or it's not. Or I can dip into the properties of the template and build a alert condition. So in this template we had CPU, memory, and disk configured. I can select that and configure an alert for greater than 90%. I'll indicate that it should trigger during the first occurrence. We'll leave some breadcrumbs here for whoever receives this alert. What should they do next? We're suggesting that they turn on SSH via send command and then fire up top and troubleshoot. And then we have two notification options today. We can send an email alert, or if there's an adjacent system in your environment, we can send a REST call to programmatically create a ticket, like in ServiceNow or Remedy. So this alert would exist for a period of time until it's fired. Once that condition is met, the alert would show up, you'd be notified or ticket created, along with a hyperlink to the actually impacted edge device. And that is a very quick nickel tour of Pulse. With that, I think we're up on time. I'm happy to take any questions you may have. Yeah. Great. Well, I'll also be outside if anyone wants to talk offline. Thank you very much.